Hey everybody, I'm Marcus Hazelwood, and welcome to Clear Haze Exchange. I'm an energy engineer with over 15 years of experience in sustainability and energy efficiency consulting. Many find these topics a little complex, so I created Clear Haze Exchange to help provide clear, actionable insight, clearing the haze, so to speak. We'll cover plenty of topics under the umbrella of energy efficiency and sustainability. Let's get into today's conversation. Welcome to another episode of Clear Haze Exchange. Today we have a very exciting guest to talk with and understand a little bit more about carbon and decarbonization from a mechanical engineering background. Kristy Walson is a mechanical engineer turned sustainability leader who's passionate about decarbonizing the built environment and helping teams design buildings that use less energy and create a healthier future. She's a principal at Branch Pattern and a LEED fellow, and she specializes in energy modeling, net zero strategy, and reducing the carbons, all the carbons, both operational and embodied. Kristy and I recently spoke together on a Global Network for Zero panel, and she also presented at the Rebuild Conference in 2024 as a keynote that I also attended, where she shared a powerful analysis on optimizing whole life carbon for existing buildings, a topic that we'll try and dissect a little bit today. Outside of work, Kristy loves spending time in the outdoors, playing sports, traveling with her husband and 3 kids. Kristy, welcome to the show.
Thank you so much, Marcus. I'm really excited to be here.
Absolutely. I'm excited to have you. Like I mentioned, you do a lot of deep diving into this area of sustainability that's not talked about a lot, particularly embodied carbon and how it relates to mechanical equipment and systems. So I'm excited to dive into that and help our audience understand more about that. So really to start out, what's one thing most people totally misunderstand about decarbonization or net zero work, you would say?
Yeah, I mean, one of the things that is a big misnomer, I think, in this work is that every single thing that you have to do to get to a decarbonized state or low or no carbon or net zero, like you were saying, is that it's always going to cost more. That I think a lot of the industry attaches an added cost to the measures that it takes to get to decarbonization, to net zero, and they miss the part where it also saves them money to operate their building. So just like you go turn the lights off in your house and then you save money on your electric bill, all of these strategies are reduction strategies for these buildings that use a lot of energy. So this is significant savings over the course of the, ownership of a building.
Yeah, absolutely. Agreed. I have plenty of experience in that as well. The immediate assumption is that how much is it going to cost to go net zero, to decarbonize, to electrify our buildings? Certainly points that have to be addressed, like you said. How would you explain what you do in one sentence?
Well, I was not I was a lit minor, but this is gonna be a run-on sentence because it's almost
Okay.
impossible to do this in one sentence. Um, I use analysis, data, and modeling tools to help buildings save energy, decarbonize, um, reduce their impact on the environment, and use resources efficiently.
That was excellent. That was excellent. I think that's great. So you pulled into sustainability and decarbonization. For people that are unfamiliar with that, how would you define that?
Yeah, so I get the benefit of teaching sixth graders once a year about the carbon cycle and decarbonization and just global warming in general. So I'm going to bring it all the way back to that and just simply ever since humanity discovered electricity and fossil fuels in particular, we have created more greenhouse gases in the atmosphere than our atmosphere can handle. The greenhouse gas effect is supposed to happen. That's how we're here, to keep the planet warm. But our planet is out of balance due to all the fossil fuel burning. And so we need to get it back in balance. And buildings play a large part in that because they use a lot of fossil fuel based energy to run. And so decarbonization simply is bringing our planet back in balance or closer to balance to mitigate for all these the effects that come from being out of balance, like global warming and a warming climate and extreme weather events and things like that. So I try to simplify it. Even that I think is too technical for a lot of people. So we do, as an industry, I feel like need to get to a place where we can have more of a story and tell these in stories rather than trying to use technical terms to do this work.
Agreed. Agreed. And some of the terms I think are used in government to where when there's regulatory, specifically, I worked in Boston and New York where they're doing carbon fining, charging commercial businesses that use more than they're expected to use for example. So these are defined as carbon fines. So if someone is unfamiliar, and they're getting a fine, they're gonna be like, "What is this?" They're gonna pay a little bit more attention to this, and it then kind of relates back to what you're talking about in terms of we're trying to bring balance to the plant. The reason these regulations exist, and they're, existing in other countries as well, is to help that overall goal that you explained. So what first
Exactly.
pull Yeah. So what first pulled you into this world of sustainability, being having a design mechanical engineering background?
Yeah, it's interesting. I think we all have our origin story for how we got like pushed into sustainability or really pulled into sustainability. I actually I did yacht design, boat design for the first 7 years of my career. I grew up on a sailboat, and that when I got to college and got my mechanical engineering undergrad degree, colleges do a really good job of teaching you about engineering, but they don't do a great job of telling you what careers are available in that particular specialty of engineering. And it definitely don't tell you about all the careers, right? And so even back then, sustainability wasn't really a word. And I went with what I knew and went and got a graduate degree in naval architecture because I was very familiar with boats. Did that for about 7 years out of college, and it was this moment of, like an epiphany moment where I was reading a magazine at my house, and it was the first time I had seen the word LEED and US Green Building Council. And I read this whole article about a house that had been LEED certified. It explained what it was, and it was really pretty immediate that I should be doing this. Like, this is what I was supposed to do with my mechanical engineering degree. It actually somehow, the article also allowed me to connect the dots that my engineering degree could be applied to this, and it was all kind of that was it from there. And right after that, like within a couple months, I got myself to a US Green Building Council meeting for Central Florida. I know some of those people still today, and that was really how I got started. Like, it was more of like this was always in me, and I just didn't know that it was a career path, and once I did, I jumped right into it.
Good. That's good. So what excites you most, about the work you're doing now, at Branch Pattern?
I'll intro Branch Pattern real quick so people know what we are. We are a sustainability firm. We have about 120 people. We also have, as part of that 120 people, a small MEP, engineering, like typical design practice. So unlike a lot of MEP firms that have a side of sustainability, we're a sustainability firm with a side of MEP. And I think the distinction is important because when I was making my move from my prior place of employment, I wanted to go to a firm that made its money off of sustainability, not off of engineering with the side of sustainability. And so within our building science practice, all of the sustainability work, that's where it all lives. And the reason I'm excited about what we do at Branch Pattern is we pride ourselves on being a one stop shop for sustainability. So we do certifications, but we also do all of the work that you need to do to get the credits to get the certification. So a lot of the testing, we do commissioning, we do all of the modeling. There's really nothing that we don't do that supports certifications, LEED included, but also well, fit well, ILFI, like all of the certifications. We can, from top to bottom, cover all of the requirements for those.
So from yachts into designing, buildings, and then really just finding a passion is what it sounds what I'm getting from you is
Yeah.
that passion developed as you are kind of designing systems and understanding the value of sustainability alongside that. I like what also you said about branch pattern being primarily sustainability with a side of MEP engineering. I'm very familiar with different MEP engineering firms that want to have a side of sustainability to launch, but when the focus is not on energy efficiency and sustainability, it's very challenging to grow a group within a primary, design firm, so I certainly get that from my own experience. So why is a built environment such a critical place to focus our climate efforts?
Yeah, well, just by the numbers, if you look at global carbon emissions, or greenhouse gas emissions, 40% of that is our built environment. So 30% is our building operations. And then the other 10% is the embodied carbon that goes into the materials that make our buildings. So, like right there, yeah, I don't love to work on tiny little slices of the pie. I like knowing that I'm working on a big slice of the pie and making, even tiny incremental changes make big differences globally. Um, and so those are good big numbers, but then when you get into an urban setting and you look across the landscape of the big buildings, right? Big buildings make up, I think it's like 50% of our global building stock, but they are 95% of global emissions. All those tiny little buildings that would be really hard to hit all of them, they're the last 5%. So when you get into an urban setting, if you look at an urban city, the carbon emissions associated with that city in that urban setting, 70% of it is attributed to the operational carbon from those buildings. So, like, that's an even bigger slice of the pie when you get into those landscapes that have those big buildings. And that's why we need to look at operational carbon, which is energy use of our existing buildings. And a lot of these buildings are old. There's a ton of deferred maintenance. There's a ton of leaky envelopes that just haven't had the attention that they deserve. So there's a ton of opportunity in these buildings just sitting there waiting for us. And I also think existing buildings haven't gotten enough attention for people like shiny new things. But we have this entire building stock that we need to improve, and we know how to do it. And it's a huge slice of the pie, so it'll make a big difference.
Yeah, yeah, that makes sense. That's a good segue into so you talk a lot about, reducing all the carbons. So what does that mean in simple terms?
Yeah. I love how you're asking me to do these in simple terms, by the way, because it's a good challenge for all of us in the industry. Like, simplify the messaging. Um, our built environment, which is our buildings, uh, the three buckets of carbon emissions that come from our buildings are the energy that the building uses to keep the lights on, to run the HVAC, all that, and that's called operational carbon. The carbon emissions associated with the extraction, manufacturing, and transportation of the materials that go into new buildings. That's called embodied carbon. And then, even though refrigerants are technically included in operational and embodied carbon, I like to pull them out as their own bucket. So, refrigerants are the one man made greenhouse gas, and they also have an extremely quick impact on our atmosphere in terms of how they affect the global warming and our greenhouse gas emissions. And so operational carbon for energy use, embodied carbon for the materials that go in our buildings, and the refrigerants associated with the HVAC and refrigeration systems that go into our buildings are the three buckets that I like to include in all the carbons. But I am not, I never like just close the door because there's probably something we're missing. There's always like something we're missing. So the door is always open for a fourth carbon, but right now those are all the carbons to me.
Yeah, yeah. And that gets into, thinking about how they're identified in terms of metrics when we start talking about the technical terms of scope 1, 2, and 3. If you could explain how those fit into those terms.
Sure. Sure. So operational carbon, we'll start with that, is covered by scope 1. Scope 1 is your on-site combustion, where you're burning a fuel on-site like natural gas most of the time to create heat. So that's scope 1. There's some other stuff that goes into scope 1, but it's not as related to the building. Scope 2 is solely for the carbon emissions associated with your electricity use at the building. And the reason it's separate from the natural gas is because those carbon emissions happen back at the power plant. You don't see it happening at your building. The wires are coming to your building and powering your building. So, scope 2 is dedicated to electricity used in the building. Scope 3 is basically everything else. But in terms of the built environment and buildings, it's embodied carbon. It's the emissions associated with the materials that go into the building to build the building. And concrete and steel are the biggest contributors to embodied carbon. But you need to look at everything.
Yeah, that's good. That's crystal clear. No, it's there's a lot there, and thanks for breaking that down because there is a lot of complexities just in that area, and then some of the terms, like I said, we use. So, where would you say that building owners or designers should start? Sorry, start. Where would you say that building owners or designers should start, given that information?
Yeah. Well, um, that's an interesting question, right? I think everybody wants an easy button. However, my first start, where I like to start, is with the data that we already have. And so some of the data we already have is utility bills. Easy place to start. Let's look at our utility bills. Are the is the use, the electricity, natural gas, whatever it is, whatever utilities are coming in the building, are they tracking in a way that you would expect? Do they track with the weather? Because you can look at the degree days, not to get too technical, but you can look at the cooling and the heating degree days for that location and map it against your utility bills and see, does this track with weather? Do I have a really high base load? Like, does it never go below a certain number and why? Can I explain that? What's going on there? So starting with the data that you have, and typically it's only utility bills, unfortunately. When I do energy audits, I also ask, like, what are the last 12 months of work orders? Because we sometimes forget that buildings are for people. And so we like the work orders tell me where people have been uncomfortable. Usually the work orders are associated with a complaint, like usually thermal comfort for the most part, in a particular area. And I'm always wanting to make sure we're doing this all for the people in the building. So if I can look at the work orders and see where, certain areas have had the most attention over the last 12 months. And then if there's any maintenance, and that's a big if sometimes, looking at the maintenance logs to understand like how well are you taking care of your equipment, or we just letting this thing run, you know, nonstop. Those are the kinds of things I like to look at. There's other components to like data you might have like with a building automation system, but there's some guaranteed data that you can look at first and just get a feel for how your building's operating.
Very valuable places to start because you wanna know what exactly do we have? What are we working with? What's the main issues? What's known information that we don't have to figure out, you know, uh, uh, we don't have to figure out through energy modeling or something else. So this leads into the next question, which I'm really really curious on how you can break this down as well. When we talk about the metrics, the scope 1, 2, and 3, you also mentioned energy modeling. So, what role do these metrics and energy modeling play in good decisions?
Oh, that's such a good question. With energy modeling, it's just a simulation of your building operating in the climate that it's sitting in. And what you can do is use those utility bills to build out the building that you have. And then as you start to consider different energy efficiency measures or like energy projects that you want to do at the building, you can start to validate the impact to the energy use of the building with an energy model. And I often find with energy modeling, you're never going to get exact, right? It's a comparative tool. It's not a predictive tool that tells you what your bill will be after you do all these, but the biggest thing that it does is help in decision making for the owner if we're talking about an existing building, and it builds out the business case. So, like I said, people forget that spending money can make you money on buildings, and this starts to build out the business case of if I spend this much money, it's going to take me 3 years to get that back in energy savings. And that can be a very compelling story for getting those efficiency measures implemented.
That's really good. There the value of it, sometimes can be lost in the upfront, like we mentioned earlier. Well, what's it gonna cost me to be efficient? Well, there is cost. It's almost like how accurate, do you want this to be? Do you want it to just be high level with some give or take, a level of accuracy that's kind of in the ballpark? Or do you wanna be within, 20, 10% of that return on investment? Like you mentioned, when we're talking about dollars, which is kind of the most important thing owners are thinking about. We want to be able to predict as close as we can for these upfront dollars that we're spending to show that, hey, there's going to be a return on this. And then also making sure that there's an ideal pathway towards getting that return. If you're showing the energy modeling, you're able to document annually the projected performance. So that's good. There's a lot of value in that, and it can't say enough the value of energy modeling. If you're not energy modeling, then what are you using to make a decision? You
Right.
can't get close to that.
Right. And I mean, I do want to add to that too. Like, I think there's a fundamental disconnect when we only look at first cost and energy savings because there's so much more to the story. I find like I'll work with owners who are like, I only consider measures that will pay back within 5 years. And I'm like, "Cool. How long are you gonna own this building?" And they're like, "Oh, no, we're gonna own it for, like, 70 years." I'm like, "Okay, great." First of all, that's, like, faulty accounting, like, you are not like and then they tell me that, and then I deliver an audit report, and they really only look at first cost. They don't care about like, I'll be like, "This is a great return on investment, 3 years," but they'll slide over to the first cost column, and they'll be like, "Oof, but that's a lot of money." And I'm like, "But you said return on investment." And I think one of the things that we in the industry can be doing is explaining there's a lot more that goes on in your bank account than just the first cost and your savings. Like, what is your penalty avoidance if you're in a building performance standard area and this brings you into compliance and you're like in a state where you're about to have to pay a penalty? What can you charge more for your leases because this is a modernized building and low carbon and people are looking for that in their leases. So we often shorten up the story too much when we're talking just return on investment.
Yeah, absolutely right. So moving a little bit more into another area of the scope 1, 2, and 3. At the Rebuild conference that I mentioned back in 2024, you were a keynote speaker. Your presentation got deep into data-driven information. What would you say was a big takeaway from that presentation that you were diving into, and a little context on what you were presenting about?
Sure. I didn't know you were in that at
Yes, I
that
was.
conference, so that was a fun little, thing when I read the questions for this. So as context, I presented a case study of an existing building. It was an industrial building that wanted us to evaluate the possibility of electrifying their heating systems. It was natural gas. The lease for the tenant was coming up, and so the systems were at end of life. They were going to replace the systems anyway, and so they were looking into, like, what would be the impact to this building, to all the components of the building if we were to electrify the or the building HVAC systems. And so, one of the big takeaways I think from that project in particular is that you have to use some data to start making decisions. Like I said, like, use what you have to start. But for instance, when we put the building into the energy model to create the calibrated model, which is just the model as the building is right now, we could not get the building to use as much heat in the model as it was using in real life, like that they were actually paying for, or as much natural gas for the heating. And we were like, what is going on here? Like, what? We're like, turning the lights off, we're increasing the infiltration. We're like, maybe they keep the doors open all the time. And so that required a site visit. We're going to do a site visit anyway. That really required a site visit to be like, what is happening here? Um, and what ended up happening is we determined it was an envelope issue. It's in Chicago, cold climate. That's where insulation on your exterior makes the most difference. Is the colder the climate, the more impact your envelope has on the building's energy use. And so we really honed in on the envelope. But that's not what they hired us for. They hired us to, like, electrify their systems. But if they had electrified their systems with the cost of electricity versus natural gas, they would have been very unhappy if they had electrified without looking at the envelope and doing envelope improvements. So that's kind of one of the big takeaways of that. You have to dive in to each individual building. There's no blanket approach to this stuff.
Yeah, no, that's a really good story, real life story. I've experienced a similar one to where it was a dormitory building and trying to understand, like you said, increased infiltration on the energy models. Like, what is it that's causing this? And I come to find out that the students were keeping windows open and leaving them open. It's almost like you put heat in the building and it just goes right out. So
That's right. Oh,
yeah,
that makes so much sense, but, like,
yeah,
you don't know that till you get
yeah.
out there
You
and
don't.
and again, buildings are for people, so you gotta
Yeah.
talk to the people,
Yes.
gotta go out there and see what's going on, and even if this building had electrified in the name of decarbonization, the location in Chicago is a very dirty grid even now, so even that wouldn't have so I feel like when you have to look at a building holistically like that, and also what the occupants are doing in the building, like your example is great.
Yeah, and then the other piece to that is if you were to size that building to electrify it, then you would be oversizing it just because
Yeah.
you're assuming that there was a load that was more than what it actually should be. The same thing happens in projects I worked on in Boston where they were trying to electrify the building, but the energy model was able to identify more of an operational condition. But the envelope and all these other aspects, components of the building have to be included appropriately in order to
Mhm.
project what that is. Otherwise, it's either oversized or undersized. So that modeling and then that in reality walkthrough of the building, understanding issues and problems, it's all critical to the success of this. So, but I think we talked about a lot of the surprising insights out of that, but what do you think, as the most surprising things to the audience when you describe successes and present this information?
I think that it's not that hard, that these strategies that get you to low carbon, low energy state have been around for a long time. They're not, like, flashy. You're not going and buying the newest air handling unit that does everything for you, that's AI driven, like, you don't need all of that. What you need is a building that operates as it was intended, maintains thermal comfort and good indoor environmental quality for its occupants, and is not just left to run, willy-nilly on its own. It needs control, so that it operates when it's supposed to, when there's people in it, but also can go to setback mode, when there's no people in there. It's all about just employing the tools that we have in an optimized way in order to get the energy use and the, carbon emissions down for a building. But it's not it's complex sometimes, but it's honestly not that complicated to achieve.
Good. So, how would you say the conversation? How is the conversation shifting from energy efficiency to carbon accountability? I mentioned how in Boston and on the East Coast, they're doing carbon fining. You described decarbonization and what the definition of that is. You broke that down. So many people are familiar with energy efficiency. Oh, we just need to be efficient, efficient. But how is that conversation shifting from energy efficiency more to carbon accountability?
Yeah, it's been a good shift, first of all. I'll just state that it's been a good shift for our industry, even though it's more complicated to explain to the
Yeah.
layperson. And that's because when you shift from energy to carbon, you start to expand what you look at. You expand the scope emissions first, like we are now including scope 3, that embodied carbon of those materials, into the conversation, but you also expand the time that you're looking at it, because when we were doing energy, like, we would look at energy use for a year, right? And okay, here's your savings over a year, here's this over a year. When we talk about carbon, we are talking about the full life cycle of a building, and that could be 60 plus years if we're lucky. If we've built a resilient building that can withstand extreme weather events and can also be independent when the power grid is down due to those extreme weather events. Um, we expand that out to the 60 plus years. And that impact of carbon is what matters the most. Like, 2050 is our date to have all this figured out, I guess. But if we're only looking at a year in time, we're not going to get there.
So we're both involved with Global Network for Zero advisors there. So what are you excited about working with company organizations like that to try and simplify the attempt to get to net zero or to reduce our scope 3? So
Yeah.
what would you say you're excited about there?
I mean, Global Network for Zero is one thing I'm excited about. Like I said, I have been really focused on existing buildings for a long time, but they don't get the attention they deserve often. Um, they kind of get attention when people don't have money to spend on new buildings, or there's some kind of other roadblock to new construction. So they're getting a little more attention now. Um, But I think, oftentimes, like I said, those big buildings that make up 95% of our square footage of our building stock, they're all owned by an owner, and then they're leasing and making money. These are assets that people make money off of, unlike your home. I mean, you hope you make money on your home, but that's not why you own your home. Like, the reason that people have these larger buildings under their ownership and then their portfolio is to make money off of them, and oftentimes, it's not the only building that they own. They tend to own a portfolio. And so I feel like GNFC is focusing on that bigger picture of existing buildings and also existing building portfolios. Um, and like, when you touch those bigger buildings and the whole portfolio, you're making a much bigger difference. That slice of the pie, there's a lot of impact and opportunity there.
That's good. What would you say is the biggest barrier slowing down decarbonization today?
So this is gonna be a really boring answer for for us engineers, or maybe anybody really. Um, I have found that a big barrier to decarbonization at these large existing buildings is their lease language. And I know that's not exciting, But what's happening is, the good thing about there's so many good things about these building performance standards that you're mentioning, like in New York and Boston, there's a bunch across the United States. The great thing about them is it's starting to like float to the surface, these issues, these barriers in a way they haven't been before. Many buildings, their lease structure has the owner responsible for the asset level equipment, right? Because they get the benefit of the increased value of the asset when they upgrade this equipment in their building. But most of these buildings, the tenants pay the utility bills. And so that return on investment that we were talking about, where like you get energy savings uh, and for your capital investment, the problem here is one person is spending the capital and another person is getting the benefit of the utility reduction. So our lease structures, typical lease structures, don't include co-benefit like language for this stuff. They've never had to in the past, but building performance standards don't care who owns the building and who pays the utility bills. They are based on the building. They don't care about the rest of that. So it's starting to get um, landlords really focused on what does a green lease look like? What is like a lease that has co-benefits for me and the tenant for decarbonization and energy efficiency measures look like? That I think is going to open the way a lot, because if they're basing everything off of that return on investment and they don't have a mechanism to make that happen, then they're never going to do these things.
That's a really good point. That's a really good point. I think about, even with implementing some of those performance standards, in my work in Boston and New York, that lease was a very challenging piece because one, how do you collect everybody's information and how, get access? So when you're reporting a building, you need all the tenants' information, and then it's challenging to, one, get to, but then when you require that building to reduce their energy and they have no control over what the tenants are doing, that makes a lot of sense. I know you focus heavily on the sustainability and energy aspect, but what would you say, successful project teams do differently?
Well, it probably depends on what we're defining as success, but I'm going to take success as low energy, net zero, achieving our energy and carbon goals. One is to set goals at the beginning of the project, that and then hold the team accountable to it. It's a pretty fundamental, um, it's a fundamental task for integrated project design. But that no, I don't see it enough, right? And so set that energy use intensity goal, that carbon emissions goal ahead of time, and then really like don't let that goal slip. You can get there a lot of different ways. It's like you pick your path, how to get there. And if one path closes because of cost, is let's find another path. But don't let them be, people tend like the first sign of resistance, right? They're, oh, our goals are, oh well, we'll just meet code, it'll be fine. But that's not okay. If we're going to make inroads, we need to set goals and hit them early on and really involve the owners of the buildings, start to remind them, hey, you have an ESG report on your website as a corporation, like, and this is like supposed to be a core to your values, and you're saying you're going to hit certain goals. This can help you hit those goals. Um, so yeah, that's what I like to see, and I'd like to see more of.
You mentioned earlier about school. Often it doesn't prepare students for careers in specific areas. What advice would you give engineers entering this space of sustainability and energy efficiency, given it touches so much?
Yeah, yeah. Such a good question. I was really thinking about this one. Well, one, my hope is in the not too distant future that engineers and sustainability engineers are just one the same thing. There's no distinction anymore, because engineering should not be just built to code. It should be build the best possible building you can within the constraints that you have, and we're here to solve problems, right? We got into engineering to solve problems, and these problems, like we said, they're not that complicated. It's just finding a pathway within the constraints that you have. So that's my soapbox pitch. Like one day, maybe we won't have to have this conversation, but today it's start asking questions. When someone tells you, "Oh, that's just how we've always done it," or "That's my rule of thumb," or "That's just like how I like to do it," because we know being at MEP firms, like even every engineer has a different way of doing things. Start really pushing against those norms. Like just because we've always done something that way doesn't mean that's how we should be doing it today. So don't let the rule of thumb kind of mentality get into your brain. Ask the questions and really focus on what you can focus on. If you're a mechanical engineer doing HVAC design, how can we reduce our system's impact on the built environment, on um, global warming and the carbon emissions of this building? Start to ask those questions at the table in meetings. Why are you only putting code minimum insulation on your building? Like what happens if we maybe increase that a little? Let me show you, because I do an energy model. Let me show you. So start to push against those norms.
Yeah, good. Favorite project you worked on?
Okay. So it's a project. It's like a life project. It's not necessarily a singular project, but you kind of alluded to it earlier. MEP 2040 is like my passion project. Well, I share it with 12 or 13 other folks that started MEP. We started MEP 2040 back in 2021. The pandemic's happening. We figured like, we're not doing anything. Let's have some meetings and start talking about embodied carbon in our MEP systems. Because if you think about MEP systems, they're the only system that touches all three of those buckets that I was talking about for carbon emissions in the built environment: the operational, the embodied carbon, and refrigerants. They touch all of it. And so fast forward to today, we started it as a commitment, like asking firms to just commit to asking for EPDs, for environmental product declarations, and the embodied carbon information for their MEP systems. And today we have over 100 signatories. We have over 100 supporters, who are people that support the mission but don't do design, so they don't feel like they don't request equipment. We have huge corporate supporters like Amazon who can really push the industry. Like they use enough of this equipment to really get the industry, the manufacturers, to start providing this information. And it's just become, born out of a passion project, this huge thing that I really never thought was going to get this much traction. I don't know if any of us really anticipated it getting this much traction, but there's huge amounts of support for it. And now, like, what progress and success looks like is now we are mentioned, MEP 2040 is mentioned as one of the criteria pathways for in ILFI's zero carbon standard. Um, if you are an MEP 2040 signatory, you are already doing all the things you need to do for MEP systems for that credit. And then there's another exciting pilot credit coming out for LEED, where they mention MEP 2040 in the beginner's guide that MEP 2040 developed. It's all volunteers doing this work essentially for no money, and putting really, really excellent guidance out there for people to be continuing this work.
It's good. We're running out of time, but I really think that you've provided simplified knowledge around this topic, and you've really cleared the haze around a lot of areas. Thanks for clearing that up in terms of decarbonization, what that is. I like the point you made about leases being one of the barriers in this movement of decarbonization. You also broke down the different areas: operational, embodied, and refrigerants. These are important things to think about, and particularly for designers in this world. I like your charge for engineers, how to think about engineering. We can't just have sustainability engineers and engineers. They have to be combined. It has to be a singular effort towards solving this problem or this challenge of decarbonization and balancing our world, like you mentioned. So I really appreciate you coming on, Kristy, and sharing everything that you've worked on, providing experiences. And hopefully the audience enjoyed our conversation. You can find Kristy on LinkedIn and also her company, Branch Pattern. Thanks again for joining us, Kristy.
Thanks. This was really fun. Thanks, Marcus.
Thank you. Thanks for listening to Clear Haze Exchange. New episodes drop every 2 weeks. You can catch Clear Haze Exchange on Apple Podcasts, Spotify, Pandora, iHeartRadio, and more. Let's clear the haze about sustainability and energy efficiency together. Subscribe now and join the conversation.